Nikola was born to Milutin Tesla, a priest in the Serbian Orthodox Church, and Georgina Juka Tesla, a woman known for her remarkable creativity. This diverse blend of religious and artistic backgrounds would significantly influence young Nikola's perception of the world around him. His family's home was nestled amidst the serene landscapes of Smiljan, surrounded by lush forests and rolling hills. This natural beauty provided a backdrop for his budding curiosity and passion for exploration. From a tender age, Tesla exhibited signs of extraordinary intellectual potential. His inquisitive mind soaked up information like a sponge, often leaving his teachers and family members astonished by the depth of his understanding. His early years were characterized by a voracious appetite for reading, and he devoured books with a fervor that was uncommon for his peers. His parents recognized his unique talents and encouraged his thirst for knowledge, nurturing his intellect through stimulating discussions and by providing him with a variety of reading materials. In the heart of his idyllic countryside surroundings, young Tesla's imagination soared. He would often find solace in the tranquility of nature, using the serene environment to fuel his creativity. It was during these formative years that he began crafting the foundation of his groundbreaking ideas. The rhythmic chirping of birds and the rustling of leaves provided a backdrop for his thoughts to flourish as he contemplated the mysteries of the universe. Despite his evident brilliance, Tesla's childhood was not without challenges. His delicate health often left him vulnerable to illnesses, and he grappled with various ailments that hindered his physical growth. His frequent battles with illness only served to strengthen his resolve to delve into the realm of the mind, seeking solace and inspiration within the depths of his imagination. As he matured, Tesla's interests expanded to encompass a wide array of subjects. From poetry and literature to the intricacies of physics and engineering, his curiosity knew no bounds. At the age of 17, he embarked on a journey that would carry him beyond the borders of his homeland, enrolling at the Polytechnic Institute in Graz, Austria. This marked the first step towards his realization of becoming an engineer and inventor. After completing his studies in Europe, Tesla moved to Budapest in the 1880s to work for the Central Telephone Exchange. It was here that he conceived the idea for the induction motor, a groundbreaking invention that would revolutionize electrical power. Tesla's development of the alternating current, AC motor, laid the foundation for the modern electric power system. Driven by his ambition to see his innovations come to life, Tesla set his sights on the United States, a land known for innovation and entrepreneurship. In 1884, at age 28, he arrived in New York City, carrying a letter of introduction and a mind bursting with ideas. Tesla secured work with inventor Thomas Edison, but their differing views on AC versus direct current, DC electricity, led to conflict. Tesla championed AC for its efficiency in transmitting power across long distances. The ensuing war of currents saw Tesla demonstrate the potential of his AC system, designing the first practical AC motor and transformer. He also devised an AC power generation and transmission system, exemplified by the Niagara Falls Power Company, solidifying his status as an electrical genius. Tesla's innovations caught the attention of investors like George Westinghouse, propelling AC power's adoption as the electrical distribution standard. Tesla's 20s marked a period of rapid innovation and advancement, shaping the course of modern science and technology. His journey from Budapest to the United States marked the beginning of a chapter that would forever secure his legacy as one of history's greatest inventors and visionaries. In 1882, Tivadar Puskás gave Tesla another job at the Continental Edison Company in Paris. Tesla started working in what was then a brand new industry, building an incandescent lighting plant in the form of a citywide power plant. The company had several divisions, and Tesla worked in the Société Électrique Edison, which was responsible for the installation of the lighting system in the Parisian suburb of Ivry-sur-Seine. There, he gained a lot of practical experience in electrical engineering. Management recognized his advanced knowledge of engineering and physics, and soon had him designing and building advanced versions of dynamo motors and engines. He was also sent to troubleshoot engineering problems at other Edison plants, being built in France and Germany. Nikola Tesla's decision to immigrate to the United States in 1884 marked a significant shift in his life and career trajectory. Leaving his European origins behind, Tesla sought to establish himself in the burgeoning landscape of American innovation and industry. Having completed his education in Europe, Tesla arrived in New York City with aspirations of contributing to the field of electrical engineering. Armed with a letter of introduction and a fervent dedication to his craft, Tesla entered the competitive realm of American invention and technology. Upon arrival, Tesla's exceptional intellect and inventive prowess quickly captured the attention of established figures within the field, including the renowned inventor Thomas Edison. Tesla found employment within Edison's company, the Edison Machine Works, initially tasked with enhancing the design of direct current, DC, dynamos. However, Tesla's growing interest in alternating current, AC systems, led to a divergence in his views from Edison's focus on direct current. Tesla's departure from Edison's company marked a turning point in his career. He joined forces with industrialist George Westinghouse, who recognized the potential of Tesla's AC power transmission ideas. This collaboration enabled Tesla to further develop his AC motor and power distribution system. Tesla's most notable achievement during this period was the creation of the Niagara Falls Power Station, which harnessed his AC system to transmit electricity over substantial distances. This showcased the advantages of AC power transmission compared to direct current systems. Tesla's contributions to science and technology, ranging from wireless energy transmission to radio technology, solidified his reputation as an innovator. His decision to immigrate to the United States facilitated access to resources, collaborators, and a platform for his work. After leaving Edison, Tesla was probably working to patent the arc lighting system he had developed at Edison. In March 1885, he met with attorney Lemuel W. Sorel. Sorel was the same lawyer used by Edison to obtain assistance in filing the patent. The lawyer introduced Tesla to Robert Lane and Benjamin Vail, two businessmen who agreed to finance Tesla Electric Light and Manufacturing, an arc lighting manufacturing and service company. For the rest of the year, Tesla worked to obtain the first patents granted to him in the U.S., and patents covering an improved DC generators by building and installing the system in Rahway, New Jersey. Tesla's new system received comments from the technical press about its advanced features. Investors did not show much interest in Tesla's ideas about new types of alternating current motors and electric transmission equipment. After the utilities began work in 1886, he decided that the production side of the business was too competitive and decided to operate only one electrical plant. They left Tesla's company, leaving the inventor penniless, and formed a new utility company. Tesla even lost control of the patents he had produced because he had assigned them to the company in exchange for shares. He had to work in various electrical repair jobs and as a ditch digger for $2 a day. Later on, Tesla stated that he suffered from troubles in part of 1886 and that he had to work for himself in various branches of science, mechanics, and literature. Moving to New York in 1884 and continuing his studies there, Tesla started to work with Edison here, but the two scientists soon parted ways as Edison kept his distance from Tesla's inventions on alternating current systems. Before Edison, no home in the USA had electricity. Therefore, the entry of electricity into the houses was possible with the direct current system developed by Edison. And Edison did not want to change this system due to economic concerns. Starting to work on new kinds of electric motors and generators, Tesla soon developed the alternating current system. The three-phase alternating current induction motor, developed by Tesla, converted electrical energy into mechanical energy much more successfully than direct current. In addition, alternating current made it possible to produce higher voltages, making it possible to transport electricity much farther and much cheaper. Parting ways with Edison, Tesla sold the patents for his inventions on alternating current generators, transformers, and motors to George Westinghouse in 1885. Thus, Westinghouse and Tesla, who tried to spread alternating current, became direct competitors with Edison, who insisted on direct current systems. This rivalry soon turned into a great commercial war. In fact, this period became known as the Current Wars. The whole world was witnessing the success of alternating current, while Westinghouse and Tesla illuminated the electric pavilion at the fair by making a much cheaper bid than Edison. Over time, alternating current was accepted as reliable, cheap, and successful, finally proven to the world, and direct current systems were gradually abandoned. Alternating current was also used in the power plants established in Niagara Falls in 1896. It was Tesla's childhood dream to generate electricity from running water here, and the systems developed by Tesla were used to transmit the electricity produced here to the city of Buffalo. Alternating current was an invention that could make Tesla the richest person in the world, according to some sources. The contract between Westinghouse and Tesla stipulated that Tesla would receive money in direct proportion to the energy produced, and Tesla received a rather high figure per unit. Because of the great success of alternating current, Westinghouse owed Nikola Tesla a sizable sum. This financial burden was so great that the Westinghouse Electric Company collapsed in 1907. When George Westinghouse spoke to Tesla to resolve the issue, Tesla tore the contract and gave up his receivables, as was later reported. The money Tesla made from licensing his AA patents enriched him independently and gave him the time and funds to maintain his own shares. In 1889, Tesla moved out of the Peck and Brown's rented shop on Liberty Street and spent the next 12 years in a Manhattan business. The series would work in the workshop and laboratory space. Areas where he worked included the laboratories at 175 Grand Street, 1889, 1892, the fourth floor, 1892, 1895, at 3335 South Fifth Avenue, and the 6th and 7th floors, 1895, 1902, at 46 and 48 East Houston Street. Tesla and his hired employees would carry out some of their most important work in these workshops. In the summer of 1889, Tesla traveled to the 1889 Exposition Universelle in Paris and learned of Heinrich Hertz's 1886-88 experiments that proved the existence of electromagnetic radiation, including radio waves. Tesla found this new discovery refreshing and decided to explore it fully. By repeating the experiments and then expanding them, Tesla tried to power the Ruhmkorff coil with a high-speed alternator, which he had developed as part of an improved arc lighting system. But he found that the high-frequency current overheated the iron core and melted the insulation between the primary and secondary windings in the coil. Tesla solved this problem by replacing the insulating material between the primary and secondary windings and an iron core that can be moved to different positions inside or outside the coil with an air-gapped Tesla coil. The Tesla coil was invented in 1891 by Nikola Tesla. Tesla developed numerous pioneering inventions that transformed the way we understand and interact with electricity and the broader realm of science. Some of his other most notable inventions include induction motor. Tesla's invention of the AC induction motor stands as one of his most groundbreaking achievements. This motor eliminated the need for direct mechanical connections between the power source and the motor, making it more versatile and efficient than previous motor designs. Tesla Coil. The Tesla Coil is a high-voltage resonant transformer that Tesla invented for studying electrical phenomena and conducting experiments. It is widely used in radio transmission, wireless energy transfer, and scientific research. Wireless energy transmission. Tesla envisioned a world where energy could be transmitted wirelessly through the air, a concept that laid the foundation for modern wireless technologies. He conducted experiments with the Tesla Coil to demonstrate the feasibility of wireless energy transmission and even proposed the creation of a global wireless communication and power distribution network. Radio. While the invention of radio is often attributed to Guglielmo Marconi, Tesla's work in wireless transmission significantly contributed to the development of radio technology. His patents and concepts, including the Tesla oscillator, had an impact on the evolution of radio communication. X-ray imaging. Tesla conducted pioneering research into X-rays and their potential medical applications. He developed early X-ray tubes and made contributions to the field of medical imaging, which would later become an essential diagnostic tool in healthcare. Remote control and robotics. Tesla demonstrated the concept of remote control through his invention of a remote-controlled boat, which he showcased at the 1898 Electrical Exhibition in Madison Square Garden. This laid the groundwork for the future development of remote control and robotics technology. Earthquake machine. Tesla's earthquake machine, also known as the Tesla oscillator, was a mechanical device he claimed could generate vibrations that could cause earthquakes. While the practicality of this invention remains debated, it demonstrates Tesla's creative and unconventional thinking. Fluorescent lighting. Tesla made advancements in fluorescent lighting technology, developing the precursor to modern fluorescent lamps. His work contributed to the eventual development of energy-efficient lighting solutions. Nikola Tesla's inventive legacy continues to influence a wide range of industries, from electricity generation and transmission to communication, medical imaging, and more. His ideas and creations paved the way for the technological advancements that shape our modern world. Nikola Tesla died on January 7, 1943, in New York City. His death wasn't sudden. He passed away at the age of 86 due to heart-related issues. Tesla had been experiencing declining health in the years leading up to his death, and he had been living alone in a New York City hotel room. Despite his contributions to science and technology, he had faced financial difficulties in his later years and struggled to garner widespread recognition for his work. Tesla's death marked the end of an era for one of history's most innovative and visionary minds.